Hi, I am Cesar. I'm a PhD student at Ghent University, and this is our online nitrate sensor. The idea with this sensor is to bring the lab to the field and perform a very dense, in the field, nitrate analysis. The idea is to have the mixing, the filtration, and the nitrate calculation with an ion selective electrode directly there in the field. This way we can have a very dense nitrate estimation of the field and use it for improving strategies of fertilization, for example in viticulture. This way we will get higher yields for a lower price.
Hello, I'm Antonios Morelos. I'm a postdoctoral researcher in Ghent University. I'm presenting you like two of our spectral instruments. We have a visible near-infrared sensor which scans samples in the range of 400 to 2500 nanometers. And this one is a mid-infrared range sensor which scans soil samples in the range of 2500 nanometers to 25,000 nanometers. Using these spectral signatures, we can actually find correlations and strong signatures for nutrients, for crop nutrients such as organic carbon or soil properties like moisture content. And we can relate these properties later to crop yield, especially for viticulture, or we can even use directly these sensors to the leaves, to apply them to the leaves and have like the spectral responses from the leaves in order to find quality traits or the grapes themselves, in order to find the sweetness and to find the brix level. These are published materials that have been done over the years using this equipment. And we, here in our university and in our group, we use this equipment in order to create mostly variable rate application for viticulture, such as for fungicide application, for fertilization, and create fertility zones.
Yes, I'm Diederik van der Stenen from Ghent. We have a winery and we only make sparkling wines. And it will be nice when the technology is there to move the ground on the stem of the plants. So when we remove that, the herbs is not coming. Is difficult for to coming. That is Chardonnay. There's just outcoming, and in the moment we need to care of the temperature, because when it's below the 0 degrees, it will dying. That's why we need to protect that the moment now for the work on the vineyard. Yeah.
Hello, I am Manuel Vázquez from Ghent University. I will show today the XRF, which means XRF sensor, which is X-ray fluorescence, and how we can use it for sustainable precision viticulture. This sensor is very useful to sense elements, for example, copper or arsenic. So with this sensor we could measure soil contamination after we did fungical applications. And how it works is it generates X-rays, and then these X-rays they kicked out some elements of the shells of the atoms, and each element has a unique spectral response, which is like a footprint of every element. And with this, we could estimate some, not just heavy metal contamination, but also some soil fertility parameters, or also soil salinity. And we could use it a lot for making site-specific applications.